All right, let's jump right in. We're talking about something that's totally changing the game for software development, AI engineering. So what is it? Well, it's all about how we build amazing apps using these massive, pre-trained AI systems, the foundation models that pretty much anyone can get their hands on now.
And why is this such a big deal right now? I mean, just look at this chart. See that line? It goes almost straight up starting in late 2022. That's not just growth, that's an explosion in AI development. We've definitely hit a new era, and that means we need a whole new kind of engineer. So let's dig into what that actually means. Okay, so here's the plan for our journey today. We're going to cover this new era of building, talk about the big shift to AI engineering, look at the new toolkit you'll need, face the biggest challenge head on, go through 6 common mistakes to avoid, and then wrap up by looking at what's next.
So, this new era, what's it really about? It's a huge change in how we make software. We're moving away from painstakingly writing every single line of code and logic ourselves. Instead, we're now working with these incredibly powerful models that are already built for us. And here's the definition from an expert in the field, Chip Huyen. AI engineering is all about building applications with these foundation models. Notice the word with. We're not building the models from the ground up. And that's a game changer, because it means almost any developer can now get in on the action.
Now, it's super important to understand that this isn't just, machine learning 2.0. It's a real shift in how we think, the tools we use, and what we focus on. Let's really break down the differences. Okay, this table lays it out perfectly. In the old world of machine learning engineering, you were building models from scratch. Now, it's all about adapting these huge foundation models. Your focus used to be on feature engineering, massaging the data. Now, it's about context construction, basically giving the model the right info at the right time. And maybe the biggest change of all, evaluation. It's no longer about a simple right or wrong answer. Now we have to figure out how to judge these open-ended, sometimes creative responses. And look at this. The 2 book covers side by side say it all, don't they? We've literally gone from designing machine learning systems, a super complex, build-it-yourself process, to AI engineering, which is all about taking these giant, ready-made models and tweaking them for what we need.
All right, so if the job is different, then the tools must be different too, right? So what's in the new toolkit? Let's take a look at the key techniques every AI engineer absolutely has to know.
It pretty much boils down to 3 main ways you can adapt to these models. You almost always start with prompt engineering. From there, you can level up with something called retrieval augmented generation, or RAG. And for really specific jobs, you might even get into fine-tuning. Let's zoom in on RAG for a second because it's so important. This diagram shows exactly how it works. See, your query doesn't go straight to the AI. First, it goes to this retriever. The retriever's job is to go out and grab all the relevant, up-to-date info from your documents or databases. Then, all that good stuff gets packed into the prompt as context. That way, the model has the actual facts it needs to give you a solid answer. This is one of our best weapons against AI hallucinations. Okay, now we're getting to what a lot of experts are calling the single biggest roadblock in this whole field. And it's not what you might think. It's not about building a cool demo. It's about figuring out if that demo is actually any good. This quote from Chip Huyen just nails it. Evaluation is the biggest challenge for GenAI apps. Think about that. For a lot of projects, just figuring out how to test the thing can take up most of your time. It's a huge deal. So why? Why is this so ridiculously hard? I mean, can't you just check if the answer is right or wrong? Well, here's the paradox. The smarter the AI gets, the harder it is for us to grade its work. It's like checking a first grader's math homework is easy, right? But what about checking a PhD-level math proof? Yeah, not so easy. And that's the problem. A lot of AI failures aren't big, obvious crashes. They're subtle. They're mistakes that sound plausible. We call them silent failures. All right, since this whole area is so new, everyone's making mistakes. It's totally normal. So let's go through 6 of the most common pitfalls that Chip Huyen has pointed out, so hopefully you can sidestep them. Pitfall number 1, using AI when you just don't need to. Seriously. For a lot of problems, especially optimization stuff, a simpler, more reliable method like linear programming or a greedy algorithm is going to be cheaper, faster, and better than a giant, expensive LLM. Don't use a sledgehammer to crack a nut. Okay, number 2 is a big one, confusing a bad product with bad AI. Perfect example. Intuit had this tax chatbot, and it wasn't working well. They thought the AI was the problem. But it turned out people just hate staring at a blank text box. The fix wasn't a smarter model. It was just adding a few suggested questions. See, it's often the user experience, the UX, that makes or breaks it, not the AI itself. Number 3, don't start too complex. Seriously, just start simple. Before you go crazy with fine-tuning or building complicated agents, just see what you can do with a basic API call and some smart prompt engineering. You'd be surprised how far that can take you. Don't overcomplicate things from the get-go. Pitfall number 4, getting fooled by a great early demo. Getting to that first 80%, it can feel almost easy. You get a cool proof of concept running and everyone's excited. But getting from that demo to something that's actually reliable enough for production, that last 20% is an absolute monster. It's so much harder. And this example from LinkedIn just proves the point. It took them 1 month to get 80% of the way there, but it took them another 4 months just to get from 80% to 95%. That final push, where you're fighting all the edge cases and hallucinations, it's a grind. Okay, pitfall number 5, don't skip human evaluation. Using an AI as a judge to score your outputs can be really helpful for sure, but you have to constantly check if that AI judge agrees with your human experts. If you don't, you could be in a situation where your metrics are going up, but your actual product is getting worse for users. That's a dangerous spot to be in. And the last one, number 6, don't just crowdsource AI ideas without a real strategy. If you just ask everyone in the company, hey, what can we do with AI? You're going to get 1,000 tiny projects that don't really move the needle. You need a big picture strategy. You have to focus on the things that will give you the biggest return on your investment. So, when you pull all this together, what does it really mean for the future? It means we're moving towards a way of building that's more systematic, more focused on the actual product, and absolutely obsessed with good evaluation. And that really brings us to the final question. It's not about can we build incredible things with AI anymore? We know we can. The real question, the true work of AI engineering, is how we're going to build it all the right way, reliably, responsibly, and effectively. And that, right there, is the new frontier we're all exploring.